In this lesson we're going to look at how to solve quadratic inequalities. Now, solving a quadratic equation, you just factorise and find the values of x. In this situation we're going to have a quadratic inequality, so we're going to have an inequality sign. When's this quadratic less than 0, or when's it greater than 0, or so on, or less than or equal to 0. Now there's two main things we have to look at here. The shape of the quadratic, concave up or down. If you prefer to think of maximum and minimum, that's absolutely fine. Concave up is a minimum turning point, and concave down is a maximum turning point. And where it cuts the x-axis, the roots, which we've looked at before. We then solve the inequality and look at a sketch. So first example here, solve x squared plus x minus 12 is less than 0. So if we're looking at that, when's it less than 0? Well, first of all, it's a minimum turning point because it's a positive x squared here. So that's concave up. Again, if you want to write minimum turning point, that's absolutely fine. Next thing we want to do, we want to find out where it cuts the x-axis by solving this when it's equal to 0. So factorise it, and x must be 3 or negative 4. Draw a wee sketch, so it's a minimum through 3 and negative 4. We are looking to find out when this is less than 0. So if we look at it in more detail here, when's it less than 0? Well, this bit here. All this area here, it's less than 0. So what x values is this? Well, it's between negative 4 and 3. All the values of x between negative 4 and 3 are when this is less than 0. So how do we write that? We want to say all the x values between negative 4 and 3. Well, negative 4 is less than x is less than 3. And that's the answer. Another example. Solve x squared minus x minus 6 is greater than 0. When's it greater than 0? So, again, it's concave up or a minimum turning point. Get the roots by letting it equal 0. Factorise it. X must be 3 or minus 2. Give it a quick sketch. 3 minus 2. And then have a look at it. So, when is this graph greater than 0? Or when does the x values make it greater than 0? Well, this time it's all the values in this direction, because it's going greater than 0 up here, and all the values down this way. All the x values down here are bigger than 0, or the y values are bigger than 0 at this point. So how do we write this? We're looking for all the x values this way, make the graph greater than 0. And all the x values down here, make the graph greater than 0. So, we say that x needs to be less than negative 2, or x is greater than 3. Just out of interest, if it was a greater than or equal to 0 here, all you would do would you have a less than or equal to negative 2, or an x is greater than or equal to 3 here.